problem we've encountered, folding partitions. Now this relates not only to joists but beams. That one? Don't think so. But in hotel space, you'll have a folding partition, and just be aware that if the floor above or the roof above gets loaded, the joist is going to deflect, or the beam is going to deflect, and there's a dust skirt on the bottom of the partition that's usually only 3/4 of an inch. If your deflection is more than 3/4 of an inch, you can't open and close the partition. Owner gets real upset. Okay, so that can solve some problems if you think about it. 1 inch is usually acceptable, or 3/4 to 1 inch on that system. I don't know about you guys, but I think all of us kind of remember the first mistake we make in structural engineering. You never make it again, but we all have made mistakes. If you haven't done anything. Okay, it's going to happen, but you learn from those mistakes. And I know my first mistake was becoming a structural engineer. No, my first mistake was I designed a hockey arena. First job I ever designed. 120-foot long DLH joist. I was a smart young lad. I was using the roof deck diaphragm. I wanted to tie that into the two end walls. But I kind of forgot that the 120-foot long DLH joists have 8 inches of camber. They were sticking above the wall. So that's a problem that I don't think I discussed here, except Larry talked about camber. But remember, they come with camber, and your details have to accommodate the camber. I couldn't tie it into the wall. I threw away 2 joists and then bent the deck down, which was fine. But you remember those mistakes. That's the only one I ever made, though, so I don't. That's probably a lie. Don't forget about seat depth changes. You might have a K-series joist, an LH series joist, 5-inch deep seat, 2.5-inch deep seat. Very embarrassing with the deck. Okay, so the key is here, if you've got this condition, have them put a 5-inch deep seat on one end, so that you don't have a step in your floor or roof. Another thing that comes up is unequal joist reactions. You might have this could be a beam or a joist girder. You might have a large load over here because you got some 60 or 70 foot joist. You might have 30 over here. It's going to twist it. And if you've provided a beam there, you've got to do something to prevent that beam from twisting. And that may be in the form of bottom chord extensions. It may be designing for the torsion, but you got to do something. Okay. Some comments on my first love, which is crane buildings, which I've really just barely scratched the surface here on some things with crane buildings because there's so much that can go wrong. One of the reasons I love to do industrial buildings is that they really do get loaded and usually overloaded. It's unlike an office building, or you just never see the load. So you know if you've done good engineering or not when you go into some of the industrial stuff. I refer to you to AISC Design Guide 7, which has a lot of comments on the design of crane buildings, as well as buildings without cranes. One of the things that's very common is the bolted butt plate joint. And I just bring this up because if the owner does not maintain the tightness of these bolts, that'll loosen up, the joint will separate. Every time the crane goes across, it goes bumpity bump, and then it will chip the rail, and then it goes bumpity bump even more, and finally to the point where it wears out the bearings of the crane. So that has to be maintained. So if you're called in, just see if those bolts are tight. You might have to replace the rail. Keep it tight. Specified mill joints for a tight fit. And make sure you use A325 bolts in those rail joints. And if you have to, use a welded joint. Welded joint will stay and it will last. The thing is, you have to consult the rail manufacturer for proper welding. Usually they're maintenance free, and plus they eliminate impact stresses. So it's costly. It doesn't deserve it on a lot of the light buildings that are infrequent use, but it may deserve it on very crane buildings that have a lot of cycles of load. This you see in some of the old buildings. You'll see crane runway girder, diaphragm plate. Probably was there to hold things in line. Probably was there to help transfer forces up and down the runway. But as soon as you put it in, it's a problem. Now, it won't be a problem if you have a low-duty cycle crane, one that doesn't have a lot of fatigue associated with it. And just so you know, if you have a class A, B, or C crane, those are sort of like, don't worry about fatigue. If you got a class D or E crane, or F, which is a mill crane, you got fatigue problems. And you have to design for it. If you have a job that's a scrapyard crane, suggest they use one of your competitors to design it. Because it'll break. It'll break. The owner has to realize there's constant maintenance with those. They're just made to be torn up. You know, AISC used to have the lateral loads and longitudinal loads for cranes in the spec. Now they're in AISC 7. But you know how we always took 20% of the lateral load? If you have a scrapyard crane, the AISE document, which handles mill cranes, says it's 100% of the lateral load. Because they're going to bury the magnet in this pile of scrap. It's not going to come out, so they're just going to start jerking on it. And finally it comes flying out and hits the column that Larry showed you the picture of. So they're trouble. But this, what happens here? As soon as you do this, that poor innocent little crane runway girder says, oh, guess what? I'm no longer a simple span girder. I've been attached in here, and now I'm a continuous girder. Oh, goody, goody, you know? So now what happens? It generates negative moment over the support. Well, the bolts and nothing's been designed for that. It was just an innocent diaphragm plate that was put in. So what happens is the bolts shear, the plate elongates, a lot of bad stuff. Okay, this has happened for so many years. You can see we said rivets. The first job I ever was called in on this was an old building in Milwaukee, and it's incredible. It had rivets. The solution was the rivets would pop and they would go flying out. And this is the old kind of mill building where they put the sash, you know, the windows up along the eave. Well, the rivets kept breaking the windows. That's how they found out. You know, they fly. So guess what? We put screening over the windows. You know, that was really good. So that's the true story. So what we had to do is take all those out, take them out, and do a proper design. Remove the diaphragm plates. Don't use them. Figure out another way to get your loads around. The other most common problem is the tieback. Well, this is the most common problem, actually, is a tieback. This one, there were several attempts made for a proper tieback. This one finally cracked. You can see someone tried to repair it with welding it, probably AWS. Continuous girder. You can actually, I don't know if you can see this, but there's a crack right here because negative moment caused some stresses that it just couldn't handle. Remove and replace with proper tieback. Design proper tiebacks. Now, what about these tiebacks? Here's what they're doing. When a beam gets loaded, a crane beam, it deflects. When it deflects, the top cord wants to shorten. Or the top flange wants to shorten, wants to come in. We're talking just a little bit, folks. And when it wants to come in, it's pulling on, if you have a tieback that's too rigid, it's going to pull and pull and pull and pull until something breaks. So, you know, you may have wondered why there are deflection limits on crane runway girders. The classic one was for a mill crane, span over 1,000, if it's a mill crane. That's not there because the crane has to go uphill. Okay? It's there because if you make the girder stiff enough, it doesn't deflect as much, and then it reduces this lateral movement, and the tiebacks last longer. That's why it's there, primarily. We'll use a detail on light cranes where we separate. If you don't separate the tieback, you've created that negative moment, it's going to break. So we'll actually use two T-sections or two angles, depending on the severity of forces. We'll bolt them here. We used to bolt here, but the bolts kept rattling loose, even though they were tightened properly. Things would get slotted. So finally we said, no, don't mess with it. Just weld it up. Be very generous with the weld and get a good tieback system. If you have a critical installation, there are some patented tieback devices. They're quite expensive, but worth the money because when they fail, it's no longer your problem. Okay? Gantrex makes a wonderful tieback. It's got a spherical bearings in here. See, this linkage allows movement this way. This way, it allows rotation. It just lets those forces disappear. So it's a good thing to do if you have a very heavy and frequently used crane system. I mentioned the deflection tolerances with no impact. Another thing that's happening, and most of these have already broken now, so I haven't seen many of these lately, was when in the mills where we used a built-up shape and we welded the web to the top flange, just as a fillet weld. These would all crack. Now that's in the compression area, but they would all crack. They would all break. And they broke for a number of reasons. One is if the things weren't quite square, which they never are, every time the crane went across in a wheel load, it would try to bend that back and forth, and now there would be tensions there, and they would crack. All you could do was air out those cracks out, fill it with weld, replace the girders maybe. I say use the recommended AISE detail and make sure the rail is centered over the web. The AISE detail is one in which if you're going to make a plate girder, you use a full penetration weld to the top flange with a fillet weld reinforcement. That's what the mill people say you should do, and they've had good luck with that. Down here you can just use a fillet weld. Is it getting warm in here? Or is it just me? I'm so excited about talking about cranes that maybe I'm just getting warm. Okay. If the rail is not centered over the web, you can again have twisting and have a fatigue problem. So this is an erection and it's a maintenance issue. Adjust your rails. Specify AISE tolerances, which I'll show you here. do not depend on ASTM A6. I don't know how many of you have ever been in a row with the crane suppliers, but they all say everything has to be within 1/8 of an inch. And it just isn't going to be. So as soon as there's some problem with the crane, it's your problem because it wasn't built to 1/8 of an inch. It's not possible. So even the steel mills, we use their tolerances. If you just go with A6, even an A6, the tolerance, sweep tolerance is 1/8 of an inch for every 10 feet length of beam. So in 40 feet, a runway beam could have an offset of up to 1/2 an inch. So you could be off of the center of the web by 1/2 an inch and be within tolerances of A6. Now that's probably not acceptable. You would probably have to have a note on your drawings for the fabricator to straighten that beam out before he sends it out. Okay. The web can be up to 3/16 inch off the flange center line. So it's conceivable to be within spec. You could have a 3/16 plus 1/2 an inch. That's pretty far. And now you're going to start to twist the girder. Okay. The AISE tolerances say runway sweep 1/4 inch in 50 feet max. And crane rails shall be centered on the crane webs whenever possible. In no case shall the rail eccentricity be greater than 3/4 of the girder web thickness. So if you have a 1/2 inch thick web, the eccentricity cannot be more than 3/8 off the center. Which reminds me of a story. A number of years ago, I designed, it may be the largest crane runway girder in the world for all I know. The crane runway girder is 280 feet long. On each side, it's a box truss. 20-foot deep truss here, 20-foot deep truss here, laced together. There can be 5 75-ton cranes on this side and 5 on this other side. So you got a lot of things to think about. You know, think over this. Plus it's over some cooling beds in a mill. And it's only about 20 feet above the cooling beds, which means temperature played a real role. The heat on the bottom cord versus the top cord. Anyway, I designed this sucker, believe it or not, laying on my back in bed because I had a herniated disc. And the owner says, "Yo, it's got a good design." So there I am, you know. I didn't have a laptop at the time, so I couldn't be doing this. But designed it by hand. You know, things get built, time goes on. I'm in North Dakota, Fargo, looking at a project, and I get a call from the office that says, I better not tell you where it is, go to this place in Arkansas, and your crane runway girder that you designed is moving. They're trying to erect the cranes and it's moving around. I think, baloney, you know, that sucker ain't gonna move. Well, it's moving. So I think, well, should I just stay in Fargo and, you know, give up the practice? Because I'm not going to fix this thing. That's a rough on the structure. Anyway, so unfortunately you can't go from Fargo to Arkansas in the middle of the afternoon and get there. I get as far as Minneapolis. I don't think I called my good friend Larry because I was sick to my stomach. Lost a night's sleep. Didn't know what was going to happen. I get down to Arkansas the next day and meet with the construction manager, who is a classic construction manager, you know, the fist-pounding type. God love him. He has a sign above his desk that says, "I eat engineers for breakfast." No kidding. So I meet with him, and he says, he's cussing away. He says, your crane runway, I said, it's moving, go out there and fix it. So I go out with the erector, and it's not moving, but it's kinked. It's got this nice S shape. And of course, you didn't build 280 feet. There were 2 splices. And I had 1-inch thick plate on the webs, 1-inch plate on the flanges, top and bottom, both sides. That, what? It's kinked. I said, boy, that's something. I think I'll go home now. No. So anyway, I said, okay, let's get a surveyor. This runway was 2,000 feet long. We start down surveying. And we get to one end of the girder, and it had, I think it had 6 or 8 3-inch anchor rods in the columns. They're big mothers. Go to 280 feet, and things don't line up. Sure enough, the anchor rods at one end were put in 6 inches out of straight. So they had set the girder down. The only way it was going to work was to kink. So they forced it in, and now we got the kink. They knew for months that it was kinked because the siding on the building had to make a 6-inch jut. Okay? Why? So anyway, okay, fix it. Now, it took 3 great big Manitowoc cranes to put that sucker up. Now the roof's on. The only way to take the roof off, take everything down, and try to fix it. Move the anchor rods? No way. So I just said, you're not going to be able to fix this. This cannot be fixed. So what we did was there were cranes, of course, aisles on either side. I moved those. I moved them to conform to the S shape. To this day, that crane runs down the aisle. And what reminded me is that we violated the tolerances on AISE because it could no longer stay over the web, the rail. However, those cords, they were like 14 by 400 and something. So they had 1.5 inch thick webs. So there was a lot of movement. But it does wear out the bearings, I think, about every 5 years on the crane. But after I find the problem, I go in to see the construction manager, and I say, guess what? You put the anchor rods in the wrong spot. Oh, yeah, I know, but fix it. You know, suddenly, it's not my problem. So it was a great story. Why we stay in this business, huh? Fun things like that. Rail clip failure, that's pretty common. Solution, replace with proper clips that provide positive restraint in the lateral direction, but the clip should allow the rail to move longitudinally. When thermal loads hit that rail, you should allow it to expand and contract. But the clip should also allow for lateral adjustment, but allow this movement. And also, I don't think I have it in here, but when you put a crane stop in at the end of the rail, leave about 2 inches between the end of the rail and the crane stop, because if you get the building heated up and the rail hits the stop, it's going to buckle the runway girders, because it's going to try to buckle laterally. If you do all that maintenance, here's hard-mounted rail clips. Here's the Gantrex's adjustable rail clip. Just remember the names, and you can get these in for proper time. You might see this situation. This is galling of the rail. That's because the crane is not aligned properly. It's not in the right spot. It's because the building moved too much. This one I remember because you see those boxes down below? I was so excited to see this because I hadn't seen the galling this bad before. And I'm out on the crane rail and taking pictures, you know, and just enjoying myself. Forgot where I was. And I did drop my camera. And it landed on those boxes down there. I don't know if it's still there or not. I can see it now. No, I picked it up, but it was very exciting. So if you have that, adjust the rails to be within tolerance. Prevention Maintenance. Talk to the owner. He better maintain his building or he's going to continue to have problems. Okay. What time will we take the afternoon break? Is Steve around? 2:40? Okay, we got time for some. Yeah, we got time for questions because this starts. What you're going to hear Larry talk about now are, all the fabricators complaining about our design drawings and how we don't have the right information and how we're supposed to do this for $1.98, but no, we've had a good time, Larry and I, but he's got some excellent points for you on the design drawing problems. But questions on anything I've talked about since lunch? I commend you. I don't think I saw anybody fall asleep. Either that or you're really good at it. And you look like you were awake. Any questions? Let's go back there, Joe. Oh, way in the back. Okay, we'll go this way. Yes, sir.
Yeah. You mentioned 240 feet is in girder story.
280 feet was that girder length.
What was the crane capacity, if you remember?
Yes, I think I said it could be 75-ton, 5 75-ton cranes on one side and 5 75-ton cranes on the other. So if you want to add that all up, that was the capacity. Pardon me?
Do you remember what depth of the girder?
20 feet.
20 feet?
Yeah. Why, you got one like that?
No, I was designing those big crane girders.
280 feet? Do you have one that's more than 280 feet?
No, I had 120 feet span.
How much?
120 feet.
Okay. Yeah.
But I was surprised you mentioned about 1-inch flange. I was surprised that it.
Flange plate.
Yeah, flange plate.
Yeah, splice plate.
Only 1 inch.
Hmm?
Only 1 inch for 20 feet.
Yeah, well, there's two of them, so there's one on top for an inch, one on the bottom for an inch. That's 2 inches.
Was surprising. Therefore, what building was this?
Hmm?
What kind of building? What kind of manufacturing building?
Steel mill.
Steel mill?
Mm-hmm. Next. Yeah.
Is there a way to tell the difference between an H and a J series joist in steel?
No. Okay, I'm sorry. Is there a way to look at an H series joist or a K series joist? J? H or J? No, I still think the answer is no. Can you look at an H or a J or a K and know which it is? I don't believe so. I think you have to bite down on it and see, if it's kind of soft, it's probably a J. But no, I don't think there's any way to look at it. That's why you got to kind of know what year it was made.
So what, did the J and the H overlap each other?
Yes. They did overlap for a while. So when worse comes to worse, again, you mic it. You may have to take a sample out, to test it to see whether the cords were A7 steel or whether they're 36 or 33 or 50 or same with the webs. Or design your system so you don't care what was there originally, as I started to say in the beginning. Yeah. I don't understand. I have not seen it. So what is it again? Yeah.
Apparently they clamp the top and bottom cord and then you can add a web, the web reinforcing to the pipes or when those. Just curious if you had seen it or had any.
I have not seen it. But you know my number, right? Okay, thanks. Now I'd be happy to look at it then. We know each other. Any other questions? This side of the room had 3. Pointing, yes, sir. AISE. E as in elephant. Okay. Mm-hmm. Yes, sir. Everybody hear the question? Yeah, it's proportional. So if it's 100 feet, what do you think it is? Half an inch. Other questions? There has to be a question from this side. Yes, sir. I was going to get really silly here with the question. And did you mean it to be a silly question? A nice tool to scrape paint with, is that what you meant? Yeah, is it okay to use a micrometer to scrape paint with? Yes, if you never want to use the micrometer again, it's okay. Yeah, you should try to get the paint off when you measure, but not with the micrometer. Okay, but get the paint off because, you know, joists, the paint thickness is supposed to be, and they call it a shop coat, it's supposed to be 1 mil, 1/1000th of an inch. Okay, but the way they dip them, and depends on which way the joist is, it could be 5 mil. It's if the paint runs down, or it can be a 1/2 mil. Okay, so yeah, try to get the best paint off as you can, or guess at what it is, and then mic it, because they are to 1/1000th of an inch. But I like the way you think, as they say. How many of you can still read a micrometer that's not a digital micrometer? Yeah, good for you. Yeah, I have gone to a digital because it's easier. Yeah. Any other questions? Steve, you had a couple of announcements, did you not?